If you need to pause the video right here just to make sure you have all this written down, you can go ahead and pause it. And let's do some problem solving. So we're given an equation, a sine function, and we're asked for the amplitude, the period, and the phase shift. Well, let's find the amplitude first because that's the easiest for sure. So amplitude is the A value, and it's actually the absolute value of A. And in this case, the absolute value of A means we're going to take this number right here and find the absolute value, which is 3. And because it's a horizontal line, you can write the equation of the midline if you want, but what we're concerned with is just the amplitude, which means the distance between the midline and the peak, or the midline and the valley. All right, let's find the period next. So to find the period, we have to use the formula. It's an easy formula. It's 2 pi over b. And this is our value of b. So we get 2 pi over 2, and when we cancel those out, we just get pi. All right, next is the phase shift. And for the phase shift, we have to do, it's another very short formula. It's C over B. So that means, remember I told you we're going to use both C and B? So that means we have to do this over this. So it's pi over 2. Now, to know whether I'm shifting to the left or shifting to the right, I just look at whether I'm adding or subtracting. Since I'm adding in the parentheses, that means I'm going pi over 2 to the left. And that's it, amplitude, period, and phase shift. Okay, so you knew it wouldn't be long before we had a word problem, right? The Earth travels in an orbital path around the sun. The closest the Earth gets to the sun is in the dead of winter at 147,093,602 kilometers away. The farthest, isn't it surprising that the closest we are to the sun is right in the middle of winter? The farthest the Earth gets from the sun is in the middle of summer at 152,097,052. The Earth is closest when time t is 0 and completes a full cycle over a 12-month period. What is the amplitude, period, and midline of a function that would model this periodic phenomenon? Okay, so let's start with the period, I think, is the easiest thing to find. So for the period, we're already given what that is. The period is 12, assuming that we're measuring in months, which it seems we are because it says that it completes a full cycle over a 12-month period. So that's our period, 12 months. We can even write the word months in there. The next thing that we're going to look for is the amplitude. No, not the amplitude, the midline. The midline would be the next easiest thing to find. So remember what the midline is. I'm going to draw a wave up here. And the midline would go right through the center, right? So like this. So if we know this value and we know this value, how can we find the one that's exactly in between? Well, believe it or not, there's a math operation that you've done for years and years and years that helps you find a number that's exactly between two other ones. So let's look at something really easy, like the numbers 8 and 10. Now you know the number that's exactly in between 8 and 10 is 9, obviously, right? But there's a way that you can find that number by using 8 and 10, and that's the average. So if you average 8 and 10, that means you add them and divide by 2, right? 8 plus 10 is 18, divided by 2 is 9. So to find the midline, we have to do an average. So to find this midline, we have to average the max and the min. So let's do that. We're going to take our maximum value, which is right here, and our minimum value, which is right here, add them together, and then divide by 2. And when you do that, you should do that on your calculator now. You should get 149,595,327. So that's our midline. And then the last thing that we're going to find is the amplitude. And remember what the amplitude is. The amplitude is the distance from this midline to the peak, so right here, or from the midline to the valley. Either way, because these two distances should be the same, right? So if we take our peak and we subtract the midline, then that should give us this distance, which is our amplitude. So that means that we're going to do this number minus this number. And when you subtract those two to find the distance between them, you will get $2,501,725. Okay. So this last part of the question says, assuming that this can be modeled by a cosine curve, find an equation for the orbital path as a function of time t in months. So here's our standard equation. We would have y, or actually instead of y, let's put f of x equals a cosine, and then bx plus c plus d. So which of these do we have? Well, we have the amplitude, which goes right here. We're not shifting left or right at all, so we don't need c. And we have d. Now, what we don't have is b, and we need that because we need to know the length of the period to get b. But we know that the length of the period is 12. So let's find b, and then we can fill everything in. So to find b, I have the formula for period. Remember, period is 2 pi over b. And I know that that's equal to 12. So now I just have to solve for b. So I would cross multiply, and I would get b, or wait, let me move that over a little bit. I would cross multiply, and I would get 12b equals 2 pi. Then solving for b, I would divide both sides by 12. And I would get, after I simplify, pi over 6 for b. So now I know what I have to fill in here, what I have to fill in here, and what I have to fill in here. So now it's just a matter of filling all that stuff in. So my equation would be f of x equals, I have to fill in a. So a is 2,501,725, and then cosine. Then I have to fill in b, pi over 6, x, and then plus my midline, 149,595,327. And that's my function. Those are big numbers because I wanted it to be a realistic problem. But once you have those values, you just plug them straight in. Okay, what is the rate of change? Remember, anytime you see the words rate of change, that means we're talking slope here. So let's find the 2 points first. So it says x equals 0 and x equals 3 pi over 2. So at the point x equals 0, which would be right here, the value of my function is -3. At the point 3 pi over 2, which is right here, the value of my function is -6. So this is the line that I want to find the slope of. Now I can do that 2 ways. I can use the slope formula, but then you're going to be subtracting with fractions. So I don't know if you want to do that, but you're welcome to. I'm just going to look at the graph, and I'm going to use rise over run. Now this time, if I start from this point, right, and I'm traveling to this point, I don't actually rise, right? I have to drop. I have to fall. So I have to go down. I have to go down 3. So that's going to make my rise a -3. Then I have to go over how many? Well, I go from 0 to this point right here, which is 3 pi over 2. All right, now we've got a fraction inside of a fraction. When you have that, a fraction inside of a fraction, you turn it into a division problem, because remember that ultimately that's what this fraction bar means. It means divide. So we're going to do -3 divided by this fraction. So I've got -3 over 1 divided by 3 pi over 2. And the way that we divide fractions, keep the first fraction, multiply, flip the second one, right? Multiply by the reciprocal is a better way to say it. I can cancel my 3's, and I get -2 over pi. That is my slope. All right, last one. Which of the following is the graph of? And then we have this. So all that we're given is A and B. But the fact that we don't have C or D can help us eliminate some graphs right away, because think about what D is. D, it represents a shift up or down. So if D is 0, right, if it's kind of like saying that we're adding 0 at the end, then that means no shift up or down. So that means right away we can eliminate this graph. All right, then the next thing we can look for that's easy is the amplitude, or A. So A would be this number, and this would mean that from the midline to the peak should be a distance of 4. So let's look at that with the first graph. From this midline to the peak should be 4 units up, but instead it's only 3. So, and you can measure it here as well. It goes down 3. So this one is out of the running. So we're down to 2. We should check these for their amplitude. From the midline to the peak is 4. Midline to the valley is 4. So these two are good. So what's the difference between these two? Well, the only difference here is that this graph goes up first and then down. This graph goes down first and then up. It appears that they have the same period, because if you look at where it completes one full cycle, it's just right here past pi over 2, right? Same thing with this one. So we don't have to check that, although we could. To find the period, we would do 2 pi over b, which should be 2 pi over 3. So that would be the length of our period, but they both have the same period. So far, those both fit the period that we found from our function. But should our graph go up first or down first? That's the big question. So I want you to think back when we looked at sine. Think of the unit circle. What does the y value do, right? Because that's what sine is. So I'm going to draw a circle right here. Here's 0. as I start to take this angle and increase it, my point is getting higher and higher and higher until it reaches a max of 1, right? It's increasing. My sine value is increasing. So I should look for the graph where the y value, or the sine value, is increasing first. Then once it gets to here, that's when the sine value decreases, decreases, decreases all the way to its lowest point, and then it comes back up to 0. So I'm looking for the graph to go up to its max, then drop down to its lowest point, and then come back up to 0. So this is the one that I want. This is not, this one's not going to be an option, and this one is our graph.